Welcome to a new podcast episode. It's been a while. Um, I've been working on a lot of other stuff, most importantly, getting the MyReps ebook published. So I've been busy. I haven't been lazy. And I thought it was time, based off of what we've seen been going on in social media lately and what's been on my mind and recent events, that I thought the best guest to host on the show would be Dr. Samuel Buckner. Uh, Dr. Buckner is an assistant professor at in the exercise science program at the University of South Florida. He received his PhD in exercise physiology from the University of Mississippi. His research focuses on skeletal muscle adaptations to resistance training, with particular emphasis on muscle hypertrophy and strength development, which is why I was so interested in having him on. I really like some of his perspectives. He has published numerous peer-reviewed articles on these topics and is known for his evidence-based approach to exercise science. He's also active on social media, a lot of great posts where he frequently discusses and critiques current trends in strength training and bodybuilding, such as the distinction between muscle swelling and true hypertrophy in high volume training studies, lengthened bias training, and whether long rest periods truly are superior to short rest periods. And I know you have some views on the recent rest period meta review by Singer Wolf and team. So we'll have time to dig into that as well. So I'd like to, I guess, start with, given the current state of research and your understanding of it, what do you think are the most important factors for maximizing muscle growth?
Yeah, that's a great question. Good way to kick it off. First of all, thank you for having me on. It's an honor to be here, and I've really enjoyed interacting with you in comment sections and various other places over the past several months. So yeah, thank you very much.
Yeah.
Um, Regarding muscle growth, I think if you follow people on social media, read various textbooks and other things, you typically see three mechanisms discussed. Those being mechanical tension, muscle damage is kind of tossed around as a potential mechanism, and then metabolites or metabolic contributions. And from my understanding, mechanical tension seems to be the most compelling of these mechanisms. And mechanical tension, I think, can be taken two ways. I actually like to think of it more as internal tension, meaning your muscle has to produce force at the fiber level. And this is independent of a load, really. So the good example or the example I like to provide for this is Counts It All in 2016, a study I was part of. Had individuals just do essentially bicep curls with no weights, flexing their muscles as hard as they could throughout a range of motion. And that produced similar skeletal muscle growth as lifting a heavy traditional 70% of 1 RM weight across, I believe it was a 6-week study, could have been an 8-week study. But anyway, it demonstrates really nicely this idea that your fibers have to produce force. And when your fibers produce force and have a sufficient stimulus through volume and fatigue, the muscle will grow. The other mechanisms, I guess metabolites are probably number 2 on most people's lists. Metabolites, as we understand it, they don't seem to play a direct role in muscle growth, meaning metabolites produced from exercise aren't acting as signaling molecules to tell your muscles to grow. There's been some interesting research, I suppose, looking at the potential of lactate to act as a signaling molecule. I don't think we're at the point yet where we're saying that that's necessarily the case, but I think there's at least one research group that would lean towards there's potential there. But what metabolites seem to do is that when you contract your muscle and you produce metabolic byproducts, these metabolic byproducts, I like to associate it with the muscle burn. So when you're training and you're getting high up in reps and your muscles are starting to burn, Um, I believe that's caused at least in part by metabolites. And if you decrease the heaviness of the load, if you go from high load training to low load training, those metabolites appear to become more important. And not because they're signaling your muscle to grow, but because they're fatiguing your muscle.
Mm.
So, for example, when you lift a heavy weight, and let's pretend you have 10 motor units in your bicep. When you lift the heavy weight, you'll need 8 of those motor units. And a motor unit is an alpha motor neuron and the muscle fibers it innervates. When you lift a heavy weight, you'll need 8 out of 10 motor units to lift that weight because it takes a lot of muscle fibers to move a heavy weight. If you lift a light weight, let's say you only now need 3 of those motor units to lift the weight. So those motor units are contracting. And eventually, because you're going to produce metabolites, those motor units will fatigue and you'll turn on the next group, right? So across a lot more reps than you needed with the heavy weight, you'll reach the same endpoint of activating and fatiguing the motor units involved in that movement. One was relying more on a mechanical load, mechanical tension, and one was relying more on metabolites. But the metabolites were just an indirect way to fatigue the muscle to get you to activate other aspects of the muscle.
Mm.
The third and final mechanism that's thrown around in discussions is muscle damage. So a lot of people have these models of muscle growth where you'll see these overlap of these circles, and muscle damage is typically included. And it's the idea that damaging your muscle causes it to rebuild and come back bigger and stronger, and these sorts of things. But interestingly, muscle damage is something that we experience high levels of the first time we train. The second time we train, we experience less of it. The third time we train, we experience even less of it.
Mm.
And we have something that we call the repeated bout effect, which means that the more you train, the more protected you seem to become from damaging yourself from exercise. So I'm very hesitant to label muscle damage as a mechanism for growth because we robustly protect ourselves from muscle damage. And I think in addition to that fact is when you train with lower loads, you produce less muscle damage than you do with higher training loads. So the light weight doesn't cause the same trauma to the sarcomeres, yet we're able to get similar muscle growth. So I guess in summary, mechanical tension activates motor units and fatigues motor units, and metabolites with higher rep, lighter weight training help facilitate that process. And some combination of those things, ultimately the activation and the fatigue of muscle activates proteins that tell your muscle to grow, and we get hypertrophy. So that would be my understanding.
Excellent. Yeah. And that kind of brings me to an extension of that, because there's, a current theory or a hypothesis that, the more damage we create, the more time we need to repair that before we can actually grow a muscle, which kind of aligns with the fact that we see protein synthesis being directed towards repair, concurrent with growth in a beginner, and once repeated bout effect kicks in and protects that muscle, we see more of the proteins being directed towards growth. But there's also this statement that lighter loads and higher reps cause more muscle damage and thus extends the recovery by up to 3 to 4 times. So we should never be doing high reps. What's your take on that?
That's an interesting take. And honestly, for me personally, I only became aware of this position quite recently. In the comment section of a post that my girlfriend had made on Instagram, and was talking about training loads, and people were in the comment section saying, well, you have a lot more fatigue with low load training, and they're implicating calcium. I think calcium kept coming up a lot.
Yeah,
And
ion influx.
I was a bit confused because, I think for some people, maybe you could make that argument, but as far as damage goes, I don't think that's true. Um, at least I'm not aware of data that would support lower load training being more damaging. In fact, um, that's one of the things that I tell individuals is, there's a trade off here. If you go with low load training, you're putting less stress and trauma on your connective tissue, which in some cases is of a huge benefit. Um, but lower load training, in general, I think a lot of people would agree causes significantly less muscle damage,
Hmm.
and leads to similar muscle growth. Now, I don't know if the person that, and again, I'm not fully aware of the model that they're implicating with low load training being more damaging and causing more inflammation. And I don't know if it's an acute thing, if the discussions are being had within the same session, or if these are discussions of recovery across sessions. And I think it's actually kind of blurring into both of these areas. Um, but I've done training studies with both low load and high load training, and people's ability to recover seems to be pretty comparable.
Hmm.
Um, and I have no strong reason to believe that low load would be inferior for that reason.
Hmm. Yeah, and also like a lot of these blood for restriction studies, they're using like really high frequencies of training, and the argument being that, well, it's a longer time and attention, longer time opening up these stretch activated ion channels, and thus you get more calcium ion influx, and this causes more muscle damage and inflammation 2 to 3 days post workout, and thus
Mm-hmm.
extends the recovery period. But it doesn't seem to agree with the studies that we have on lower load high rep training, where they're actually able to do higher frequencies than the higher load low rep studies. So
Mm-hmm.
it's kind of confusing to me as well.
Yeah, and I'm open to the possibility. I think it's always important to remain open to new ideas, right?
Mm.
Um, and just different ideas, I guess, for that matter.
Hmm.
But
Sure.
when I think about calcium being implicated as one of the primary mechanisms, I believe that calcium is implicated when you have structural damage to the membrane of the fiber, which allows too much calcium into the fiber.
Hmm.
And I would associate that more with high load training. Um, now, if I were to craft an argument for that side, maybe the argument would be inflammation in the days post low load training. Sometimes inflammation for remodeling causes membrane damage, which could allow calcium influx, which could maybe activate a muscle damage pathway. Um, but again, if these things do exist, I don't think they're on this drastically different level that makes one form of training inferior to the other. I think overall, if you look at over the course of training studies, the outcomes time and time and again are very similar.
Hmm.
And for that reason, I'm comfortable saying that low load training and high load training seem to be similarly effective for skeletal muscle growth.
Hmm. Yeah. And likewise, the repeated bout effect. And
Mm-hmm.
I recall there's not a lot of studies comparing linear to reverse linear periodization, but in general, it seems as if when you use a linear periodization starting at lower loads, higher reps, and as the protective effect begins to occur, then staying ahead of that adaptive curve by gradually increasing loads seem, at least in theory, to be more effective than the reverse, where you start with high loads and then with low loads. But then again, we have daily undulating periodization studies using both high and low loads in different combinations. So that might
Mm-hmm.
be premature of a conclusion. But do you think this implies like the whole, because they're so paranoid of muscle damage, we should just avoid doing anything that causes fatigue? And here you're actually saying, well, fatigue seems to be one of the mechanisms of muscle growth, and the more advanced you are, the more at least we can assume, the more fatigue resistant you are. Although you are also stronger using higher loads, you have worked up to that point over several years, maybe decades of training. So there should be some adaptive mechanisms. I mean, it's kind of part of the adaptation process, and I guess related to that, do you think training variables should change as someone goes from beginner to intermediate to advanced, or does it kind of all work equally well just relatively to that person's strength level?
Yeah, I think I would lean towards the latter the two suggestions you just made.
Mm,
Um, the mechanisms for muscle growth, as I understand them, are the mechanisms for muscle growth.
mm,
So the techniques to try to exploit those mechanisms to induce growth, I believe, are going to be similar between an untrained individual and a trained individual. The primary differences being, perhaps, obviously there's technique development that happens as you go from untrained to trained. There's development of the mind muscle connection as you go from untrained to trained.
mm,
And I think there's also this idea that as you go from untrained to more trained, it becomes more and more difficult to get muscle growth. To me, that makes a lot of sense because, you know, if you've been training for a number of years, I believe that you've achieved most of the muscle hypertrophy that you're capable of achieving.
mm,
And any additional hypertrophy, if you think about it, you know, you're as a human, your body doesn't want to keep getting larger. It's it's it requires energy, and energy. If you look at any theory of aging, there's just not a benefit to having more and more. It's
mm,
a burden. So I think at a certain point, you're fighting your own negative regulators of muscle growth, meaning, your body is telling it's the internal mechanisms are saying this is our limit. And I think, there probably comes a point for a lot of people where, certainly not on every muscle group, I think it's very difficult to train in such a way that you're maximizing every muscle group. But I think in many instances, a lot of people have probably gotten 90% of what they can get out of their muscles. And I think that extra 10% takes probably amount of detail and attention that's difficult to give to training if you have a career, a life, a family, and these sorts of things.
mm,
So I think that attention, maybe for short periods of time, you can get that little bit more out of your muscle, through increased training frequency, perhaps increased training volume to a certain extent, consistency. But then, a lot of that's also going to rely on the other factors, and this is why research, so often it's like, y'all's chances of seeing a difference here are so tiny.
mm.
And with the sample size you employed, I just don't think there's any way you're going to see it. And even if you do see it, I don't know if I believe it, because we're chasing sometimes just this such a tiny thing that it's just never going to be realized. But I think the point I was getting at is, when you add in sleep, when you add in diet, when you add in all these other things, it's just maximizing muscle growth, which is what a lot of people seem to be interested in, is a difficult thing to do.
Yeah, it does speak for specialization. The more advanced you get, where you could put focused effort into one or two muscle groups and try the best you can to maintain the rest. But what I keep saying is that we can micromanage and ruminate and have these discussions all day, but at some point it's your genes and hormones that ultimately determine how big you're going to get. So
Mm-hmm.
feel free to dedicate your training career to get the absolute 100% maximum muscle growth in every muscle group, but it might require time and effort that's just not there unless all your ducks are lined up in the proverbial row, so to speak.
Yeah, yeah, I definitely agree with that.
So my personal bias here, if you've heard of it, what do you think of the effective reps model, which I created in 2005, that posits that the last reps of a set are more stimulating for muscle growth than the first reps because, it maximizes muscle fiber recruitment and mechanical tension through the length tension relationship. Does the concept of effective reps align with current research findings?
Yeah, so I've given this some thought, and the way I approach most things is I try to explain them physiologically. So I try to come up with, okay, if I were to write a paper on this, how would I detail this and how would I explain it? And honestly, I think it depends on how you're training. So I think if you're training with a low load versus a high load,
Exactly.
I think this discussion actually changes a little bit. And that
That's
actually,
my point. Yeah.
kind of that way of thinking actually makes it more interesting, right? Because if we think back to when I detailed my view of mechanisms of muscle growth, it's about activating, fatiguing, and creating that signal. Now, when you lift a heavy weight, in that example, I said, well, your first rep, you're recruiting the majority of the muscle, and by the last rep, you've fatigued the majority of the muscle. Now, with low load training, it becomes a different thought experiment, because your first rep, you're recruiting lower threshold motor units. And maybe in the first 10 reps, you've fatigued some of those motor units. And the next 10 reps, you fatigue some of the other motor units. And in the last reps, you've fatigued other motor units. So I would really rack my brain on which one's most effective. For me, it's more like, well, we got to this endpoint. I think it's important to get to this endpoint, but you cannot get to that endpoint without going through these 3 reps. These 3 reps allow you to do the last 3 reps. Exactly. And most people are saying, well, we have to do these last 3 reps for it to be effective. But these 3 reps here are not effective if you didn't do these 3 reps. And I have kind of a cool study that I think you might appreciate. So my lab, it was probably a year and a half ago now. One of the things we research is blood flow restriction. And blood flow restriction to me is just another tool to study and better understand skeletal muscle growth. And currently, there's no reason you need to do BFR. BFR just typically decreases the number of reps that you have to do to reach fatigue and to grow a muscle. But I had this idea. No one recommends using BFR with a high load, because a high load you can only already do, 8 to 12 reps. So BFR, what's it going to do? It's going to decrease you to 3 reps. And then, how's that helpful?
Yeah.
But we had this study design where I inflated a cuff with a pretty high pressure on the top of someone's arm, and I had them just stand there for 3 minutes. And they stood there, and it was painful. It was discomforting. And I don't know if you've ever tried BFR, but it's just, it has this unpleasantness to it. But also, when you don't contract your muscle and you apply the pressure, you don't get that temporary relief of contraction. So when you apply BFR and you contract your muscle actually squeezes your vasculature and pushes some of the metabolites out. So you get that temporary relief from the contraction. When you're just standing there, you're getting less oxygenated blood to your muscle, and your venous pressure is very, very low. So you're getting this pooling of blood in the muscle. So there's just a pooling of blood, and it's uncomfortable. So anyway, we had people stand there for 3 minutes. We inflated this cuff, and then we handed them a high load. And we said, you're just going to do 3 reps. You're not going to do you're going to do 3 reps. And then we rested. We had them do 4 sets of 3 reps with a high load. Now, typically, we would recommend 4 sets of 8 to 12 repetitions with a high load. The idea of this study was we wanted to get individuals to the last 3 reps of the set from the beginning. So that was the idea. it didn't work. I still think the
Interesting.
idea was really cool. Like we had a fun time designing it and trying to perfect it. And basically I wanted to see, can we get away with very low volume, high load training
Mm,
by making the first 3 reps like the last 3 reps of the set.
I like the way you think.
And
Yeah.
it's such a weird study, but it was just so different and fun. And I one of my students presented on it, and it was like the idea was definitely really cool. I think our execution was good, but it didn't lead to the same growth as training without the BFR to failure.
Mm,
And to me, we basically concluded that you can't um, you can't just jump to the end. Even
mm,
with metabolites, you also need the fatiguing contraction along with
yeah,
it. And I think this almost pairs with your idea pretty nicely.
it does. Yeah.
And I will not claim that our study was perfect. I will not claim that this idea couldn't be executed better, because you can always refine your methods. But as a starting point, to me, it was interesting. It's like, okay, you still need sufficient volume to some extent,
Mm,
and you can't skip to the end of the race. At least in this instance, we tried to. Maybe someone has a better idea of how to. But in this particular instance, you couldn't skip to the end of the race and get all the benefits of running the full race. So hopefully that makes sense what we did.
yeah.
But that's what we found in our study.
That's fantastic. You have a dream job. I'll give you that.
I do love it. I'll tell you, I love my job.
Yeah, that's also very apparent from your energy when speaking about these things. So, and that kind of brings me to the next point, the whole training volume debacle.
Yeah.
You wrote an excellent paper titled "The Dose Response Relationship Between Resistance Training Volume and Muscle Hypertrophy. There Are Still Doubts." And you take issue with the current trend of high volume training for hypertrophy. So the question is the premise of junk volume a point of diminishing returns valid when it comes to muscle? We touched on the whole swelling, muscle damage concepts. So what do you think?
Yeah. So, well, first of all, thank you. I'm glad you enjoyed the paper. This was also, I think, for me, it was a fun one to write. And honestly, this paper, I've had discussions on this exact topic for so many years now. There are still doubts part,
Mm.
and I we got a lot of pushback when we published this paper. People did not like this paper, but it's so interesting to me, because the science you get on social media and the science you get just in an academic environment are not the same thing.
Mm.
So, for example, on social media, this paper is horrible.
Yeah.
It's lazy. It's this and that. I mean, I've heard such bad things.
Mm.
In academic circles, it's just productive conversations, and it's discussions of, yeah, we've noticed this for a long time, and I'm glad you wrote this paper. It's a really interesting perspective.
Mm.
And what inspired it for me was, I had heard a lot on social media, and I'm a consumer of content because I love this field. I listen to the podcasts because I want to keep my pulse on what people are talking about, what people care about. And the volume thing, I just kept hearing the importance and the dose response relationship of volume. But I knew in my mind that a lot of the studies that they were basing this on, to me, were not compelling. And, I always assumed, so we critiqued, I think the Schoenfeld volume study for me saw so much muscle growth, a level of muscle growth or a change in muscle thickness that, I think there's swelling and inflammation there, because I do not think that type of change is possible over the time period that it was observed. And again, just that that critique or that point seems to be controversial on social media, but it shouldn't be. It's just a perspective, right?
Yeah.
This idea that, is this amount of growth a lot of growth? Well, objectively, I think it is. It's 3 to 4 to, in some cases, 7 times what other studies are finding. So let's talk about it. Let's figure out why this is happening. And, I made the suggestion in this paper that if you're doing high volume training, is there a possibility that there's more swelling and more inflammation? And I was talking to my partner, Holly. She's an IFBB, so she does a lot of training. She's at a high level. And, anecdotally, she said, when I do high training blocks, I get puffy. Like I have inflammation. I believe that that's the case. So we're doing actually a study now. We've designed a study to employ high volume, and we're going to see if you get like prolonged inflammation. And to be honest, I don't even think that that's what we're going to find. I don't think there will be. In this particular case, I point to the possibility of swelling and inflammation because for me, right, it's my view, and I'm glad to disagree with people, and we can. One of the things that's become apparent to me, social media doesn't allow disagreement and discussion. Just let's have a back and forth. Let's talk about this, right?
Yeah, I agree.
But for me, that amount of growth is not possible. I don't believe it's possible. Therefore, the alternative is it's swelling or it's error of measurement. Yeah. So for me, it's more likely that it's those two things than volume is that effective for growth. From a research standpoint, I think my biggest critique of the volume literature is simply the study designs that are being employed. And let me provide an example. In research, let me just give a really, really basic example. If you're going to do 6 sets of chest, right? A volume paper would do 6 sets of bench press versus 3 sets of bench press. In my opinion, that's not a good way to look at volume. Or, the recent volume with the 52 sets paper, they added volume, but they stacked it up on the same exercise, right? So 9 sets of leg press, 8 sets of knee extension, 9 sets of squats, something like that. Yeah. And I actually really like the NS paper, and I love Dr. D'Souza at University of Tampa. I think you might have had him on, but he's wonderful. He's great.
Yeah, he's great.
But anyway, the way we're studying volume in research is by just cranking up the sets we're doing on each exercise. But that's not how people train. If you told me, if you said, I'm doing 25 sets of quads a week, well, I know you're not doing 25 sets of knee extension and only knee extension.
Yeah.
Right? But in research, I don't know why. We're just crank up doing the same exact thing. And if you look at studies, most studies, you do a set, you increase muscle protein synthesis. You do another set, you increase muscle protein synthesis a little bit more. You do a third set, you get just a little bit more, and then what happens? You plateau.
Yeah.
So
exactly.
If muscle protein synthesis is plateauing somewhere around the third set, why would you do 4, 5, 6, 7, 8 sets? And what can you accomplish out of those sets? So what I tell individuals, and this is kind of maybe a newer idea, but if you want to do more volume, go to a different exercise and do additional sets on a different exercise. And I believe on that next exercise, there's still overlap. So there's some muscle fibers in that. Let's say you went from a flat bench to a fly. Well, that fly, you've already trained a lot of the fibers involved in that movement. They've already been maximized in that training session, but you might be hitting other fibers that you didn't hit on the chest press that now you're getting in the chest fly. So when you do those 3 sets, you're maybe getting a little bit more growth.
Yeah.
Right. So if you're going to add volume, to me at least, it makes sense that volume should be dispersed across a variety of movements to increase the potential. Yeah. But from the standpoint of just increasing volume because there's a dose response to volume, mechanistically, physiologically, I it doesn't make sense to me.
Mm.
Um, yeah, it doesn't make sense. And also, even if it were true, there has to be a limit on how much growth you can get over a period of time, right? So, you know, over 8 weeks, how much tissue is an organism capable of putting on,
Mm.
right? So you got the internal signaling, but then you have the overall just demand um, on from the stress to adapt. And I think when you consider all of these things, it just makes sense that there is such thing as junk volume, and I think a lot of people are probably doing more volume that's necessary to maximize adaptation.
Yeah, and it's like based on the premise that if you do more volume than the next guy, you're going to end up bigger over time. Like it can be extrapolated into the future. And then we try to kind of correlate with, well, what are the best natural bodybuilders doing? So, let's take drugs out of the picture. And to me, I think we have great bodybuilders maxing out, the fat-free mass index on both lower and higher volumes. And to me, it kind of boils down to what can you sustain over time instead of just chasing the max all the time.
Yeah, I agree with that. I think different people have different capabilities to recover, and even to like, so some people can probably train with higher frequency than others, and
Mm,
maybe that's a more effective way to allocate volume, because you could add sets on that exercise on the training day, or you could disperse them across the week, and maybe that's going to be more effective. But maybe not everybody can train that way.
mm.
So yeah, I think there's definitely genetic differences in people's ability to recover, and then probably, as you mentioned, also differences in abilities to respond to different training volumes.
Mm.
So there's an individualization component as well.
Yeah, and that's where I spend most of my time. It's trying to figure out how can we individualize training prescriptions, and we can go off averages from studies which are short term, but extrapolating those into infinity is a difficult task, and we still end up at the same point where we're going to have to start somewhere and see how that individual responds, how quickly they recover, what happens if you do, do you get more out of more volume? And if you don't, is it
Mhm.
worth it? And even all the way back in the 60s, I keep referring to Theodor Hettinger's Physiology of Strength at the Max Planck Institute in Germany, where they saw that those that were high responders tended to also stagnate and regress faster because their connective tissue simply couldn't keep up with the growth rate of a muscle which is way more plastic and has a higher protein turnover rate than connective tissue and joint. So there's like a bioenergetic system that needs to keep up with the demands of a single link in that chain, and I don't think that will eventually catch up to you.
Yeah, um, I agree, and one of the things you said about taking the research and then trying to apply the research. Um, I think one thing I've noticed in the past couple of years, perhaps, is the scientists are communicating more,
Mm,
um, in kind of like an influencer type fashion, and it's almost led to um, overvaluing the science in some cases, like saying we have evidence for this and we have evidence against this. Um, but so often it's we have evidence for this in this instance,
yeah.
or we have, there's, I think there's almost an like a overvaluing. I'm a scientist. I'm a PhD. I have this knowledge, and then almost overvaluing it, and then undervaluing the experience that a lot of coaches and individuals that have worked with so many people.
Mm,
And what a coach like yourself does is a form of science.
yeah.
You employ things, you collect metrics, you look at data, you make changes, and In a lot of ways, you have way more data than I have. And, it's a little different, but it's not of less value.
Mm.
In fact, oftentimes what I produce is of less value because there's more chains on it, and it has it's controlled in a way that is just answering such a specific question. It then becomes very important how I communicate that finding so that people don't run off and start doing the wrong thing.
Yeah.
So, for example, like going back to volume is as our example, when people say there's a dose response relationship to volume, well, they're typically talking about when you just do the same exercise, in the context of training twice a week and sometimes only training your lower body. So, like,
Mm.
what you can actually conclude is that when training twice a week for 8 weeks and only doing 3 exercises, this is what we found.
Yeah.
Well, how does a practitioner take that and use that? And I think that's when we're guilty oftentimes of speaking in these absolutes and telling people, oh, well, we now know this. Science has
Mm.
shown this. Well, a study has demonstrated that when doing this, and this outcome was measured. And then oftentimes forgets to tell you that they talked about a difference, but then when you read the results, there wasn't a statistical difference.
Mm.
And it leaned a certain way, but with the error of their measurement, it actually turns out there's nothing.
Yeah.
And I can't tell you how many times that's the case when people are being communicated science. So
Yeah. And you have a lot of great demonstrations of that on your social media. So I encourage everyone to go check that out because it kind of,
thank you.
yeah, puts a spotlight on the whole absolute versus relative differences. You can
Yeah.
inflate numbers by using percentages, but the absolute difference is so tiny that it could easily be explained by measurement errors.
Mm-hmm.
And also,
Yeah, I've
that we kind of all want to find this optimal prescription, and people go insane in the comment section and tell me what to do. Should I do 2 sets or 3 sets? And that what kind of drives me crazy, that these influencers are building a huge following, trying to break it down into this cake recipe, where you use this much of this and this much of that, and that will always, taste good. Whereas,
mm-hmm.
From both what you're saying and what I'm seeing over months and years, I can have two clients that on paper are the same. But once you start programming, then, after a year, the program looks completely different in terms of volume and frequency, simply because that's what we see happening, that one person just isn't recovering. Low responders, non-responders, people are losing muscle, people are growing muscle from the exact same training protocols and studies even. So
Mm-hmm.
why not in the real world?
Yeah. Yeah. And again, I think this is where research just sometimes comes with that ego
Hmm.
of dismissing the coach because it comes from a place of authority. And, one thing I try to be careful to do is, remember that I don't know everything, and that my study is just a very, very tiny piece.
Hmm.
Um, so, giving these recommendations, and oftentimes what you see on a post one week will contradict the post of the next week. Um, but what what PhDs often get very good at doing is speaking in a way that you always sound correct,
Yeah.
even if it's contradictory and maybe just needs a bit more caution, which is almost always the case.
Yeah. Yeah, kind of also brings me to the next point, because you said, in research, we're looking at a specific frequency and a volume, and this is what we get. Looking at isolated training of, for instance, the lower body. And again, some of these influencers are trying to extrapolate from these types of studies into general guidelines. And one of the current ones that basically is just, what's old is new again, this concept of high frequency training. I started my training career back on Brian Hickok's HST board, which was based on full body training 3 days per week with a low volume per workout, because we wanted to have a more constant growth stimulus, more first growth promoting sets, and be able to recover in time for the next workout, basically, to kind of stay anabolic. And so the current claim is that a muscle can only be anabolic for up to 48 hours before becoming catabolic, and atrophy begins. And what's going on? If you're creating too much muscle damage, you're just prolonging the recovery period and inhibiting your ability to stimulate muscle growth with a higher frequency, and thus wasting time. Um, and this again points out that most of the studies comparing higher and lower frequencies have been doing excessive volumes, and thus it looks as if higher frequencies don't work because they're simply not recovering between workouts. So, in order to optimize the stimulus fatigue ratio, we should, have a low volume and avoid length and bias movements and high reps and all that, which we discussed earlier, to allow for more frequent training of that muscle. And my question to you is: there actually scientific evidence or physiology to support that claim?
Yeah, so I think frequency is an interesting one, and my colleague Scott Dankel, he was the lead author on a paper we worked on. Just to kind of review, outlining the physiology and the potential of higher frequency training to lead to greater growth, and some of that like anabolic signaling that you alluded to. I think it was Stu Phillips in like 1996, and then Bird in 2011 looked at some of that protein synthetic response. And in untrained individuals, it lasts up to 48 hours, like elevated muscle protein synthesis from a training bout. But as you become more trained, it seems to last about 24 hours, right? Which creates this idea that, this is going up and then it's coming down. So let's stimulate it as often as possible to spend as much time in an anabolic state as possible to maximize muscle growth adaptations. And, I might share two perspectives here. And one is the arrogance of research, right? If you do an 8-week study, 2 times a week compared to 3 times a week, again, a limitation of this study is always going to be the sensitivity of your tools and your ability to measure a difference. So just because there isn't a difference doesn't mean there's not a potential for one form of training to be superior to another. But science just has this limitation that demonstrating a difference requires a certain effect, and you're not always going to have that effect, especially with all the noise of just having different individuals and then measurement error and all these things. And then secondly, I think another interesting concept to kind of throw into this mix, and this might be where your idea of genetic differences comes into play, because just because you recover and can do more volume doesn't guarantee that you can grow more. Excuse me. And what I'm getting at here is, let's say you do provide more stimulus for muscle growth, but your body simply doesn't want to grow. The added frequency is not going to do anything. Or if your body's on some level just controlling the rate of growth, meaning that you're protecting yourself from rapid muscle growth. And, that's maybe not a super evidence-based idea, but there was a paper years ago now, I guess probably around 2016, and it looked at molecular breaks of skeletal muscle growth. This was in a rodent model where they used synergistic ablation. So they cut one of the muscles, the other muscle was overloaded, and it caused rapid muscle growth. But what they found was there was a huge uptick in signaling. but then there were several mechanisms or pathways that were activated to blunt that, to like slow down the muscle growth.
Yeah.
Now that's an extreme example, but it does show that there's negative regulators of growth. And they identified several. I think they identified at least 4 negative regulators of growth. So there's at least some potential that you do more, but your body simply doesn't want more adaptation, right? I think that's at least a possibility.
Mm.
And maybe this is something that you've seen in your own coaching, in that, okay, I apply this knowledge. I know I can get more anabolic stimuli in this individual. And in theory, this would lead to more growth. Maybe for one of your clients, it works. And maybe for another client, it doesn't work.
Mm.
And I think this is just one of those crossroads where science can give you principles, science can give you ideas, but I don't think science can perfectly answer the question. In some people's minds, it can, because there's a study that shows that 3 times a week isn't better than twice a week.
Mm.
But that's a study with a lot of limitations, and it doesn't negate the possibility that that is the case. It's just something that's difficult to demonstrate. And it's difficult to demonstrate these things because there's going to be a lot of variability in the response. And maybe only 4 people are going to be able to grow more with the frequency. But then identifying individual differences, when you only have 10 people or 12 people in each of your training groups, you're just not going to be able to do that. Statistically, that it doesn't work. So I like the idea. I think someone like you is actually in a much better position to answer the question than someone in my position. So I value your insight on this one.
Yeah.
But physiologically, mechanistically, I can get to a point where I could say I see the potential. I don't have evidence, but I see the potential and I see the rationale, if that makes sense.
Yeah, makes a lot of sense. And just like you said, I mean, there's huge individual variability, and some do respond really well to higher frequencies, and some muscle groups respond better in some exercises. But
Yeah.
to me, it looks at least as if those with, whether it's more fast twitch dominance, the more explosive sprinter types, the ones with low work capacity, where you see a huge drop off in performance from one set to the next. Not only does it seem to put a cap on the per workout volume, but it also seems to affect frequency. It's not as if you can compensate for that by just, doing one set 3 times per week.
Mm-hmm.
There's still, they're not improving even with just that one set. And so it seems as if scaling that to 2 sets and allowing 3 to 4 days before they hit that muscle again is just better, even if it in theory should be better with high frequency. So that's kind of where theory meets real world.
Yeah. And the example you provided, I think that's probably more of the case. So I think if frequency is playing a role, I think it's probably the minority, because I think we would have picked up more of a glimmer of hope in some of these studies. So I think the example you provided is probably most. I think it's probably the unicorns that can respond to the higher frequencies.
Yeah, and I try to figure out ways to, over time, it's more of an art than a science, being a coach, where you kind of see trends and you use your intuition. And sometimes it's not even the training prescription, like you just, alluded to earlier. We have to take into account, are these people sleeping? What are their stress levels and their nutrition? And, on paper, this should be working, but it's not. And I spend probably way more time going deep into rabbit holes on the clients that nothing seems to be working. And perhaps it even ends up being just, below normal testosterone levels. So it doesn't matter what you do. They're just unable to, they don't have the hormonal milieu to support that.
Yeah. I'm glad that you said that, because I talk about the art of coaching in my class,
Hmm.
I said, you can learn everything here in the classroom that I have to teach you, but it can't replace the value of experience of getting out there and working with individuals and realizing that applying every scientific principle that you learn perfectly is probably going to make you a pretty bad coach.
Yeah.
You need to have the art of coaching plus the knowledge of science, and then that's that intersection that I think is a really great place to be.
Yeah, and if all you have a hammer, everything looks like a nail, you know. So just have more tools in the toolbox and know when to use what, I think is what the art of coaching is all about. Being curious about the client, observe, analyze, have, you know, an analytical mind and test and adjust, you know, pull different levers and see what happens. It just needs, to me, to be a more systematic process and not this ultimate prescription kind of seeking that seems to be going on these
Yeah.
days.
Yep.
So let's
I agree.
go to the next one, which I know you have some pretty strong opinions on as well. The trend of emphasizing exercises that place muscles under tension in their lengthened position. Is there evidence to suggest that this is as superior to hypertrophy as they're claiming these days, even lengthened partials?
Yeah. It is interesting that those two things have actually been pretty conflated. The idea that you need to pick exercises that accentuate the lengthened position, but then you also need to accentuate the lengthened part of each exercise.
Yeah.
And I think when you approach research, these are two different questions, right? They're two very different questions. And
Yeah.
I was in the gym the other day with Holly, my partner, and we were training and we were doing a seated calf raise. And, there was a post that went up talking about how bad that exercise is.
Mm.
And I said to Holly, I said, it's interesting. I said, fatigue and activation can't grow muscles anymore.
Mm.
It's like if you're providing a stimulus and you're training a muscle to the point of failure, it's interesting that we've come to a place where we're acting like that's no longer something that works.
Yeah.
Um,
Good point.
and there's been several moments like that where, okay, yes, this muscle doesn't hit this exercise doesn't hit the muscles the same as this exercise, but this exercise can fatigue and it can activate muscle.
Mm.
Therefore, it can grow muscle. And to act like it can't, it doesn't make sense to me. It's sensationalism.
Yeah.
When this idea first got brought to my attention, I made the mistake, I suppose, of interacting online. And it was pretty simple. The Goto paper has been and continues to be used as a piece of evidence that partial range of motion is superior to full range of motion.
Mm.
And I think this one paper can provide maybe why I think people need to have caution on this topic just at large. So I pointed out to this individual, I said, hey, I noticed you're talking about this Goto paper. I said, they saw like 47% increases in muscle CSA. I said, that's a red flag. I would say we need to be really careful about how we communicate this piece of evidence. And I said, it's probably because they estimated muscle CSA from, I don't know if it's muscle thickness and circumference measures, which is not a good way to measure CSA. And CSA of the triceps, that's going to include your bicep.
Yeah.
So the Goto paper did a tricep extension and it did full range of motion versus a mid range of motion. And I kind of explained that the changes in muscle size here are unlike anything you'll find in the literature. Like a typical change in CSA of the triceps is going to be 6 to 8%, not 47, 48%.
Yeah, it's crazy.
That matters to me, right? It matters a lot to me. So I pointed that out. And I also pointed out that I said, you're also suggesting that the middle range of motion group spent more time at long muscle lengths and compared to the full range of motion. I said, but the full range of motion is the only group that went to a long muscle length. The other, they stayed in the middle.
Yeah.
And, but they said, no, but the partial range of motion spent more total time under tension at what we would consider more long muscle lengths. And that's using such a, you have to do so many backbends to arrive at that perspective.
Yeah.
And I've just never seen anything like this. And when I was kind and courteous in this comment. It's on a YouTube video. I was told to go read more. I was told I'm not ready for a discussion.
You need to study more.
That's how I was treated. And
read more books.
Yeah, that's what I was told. And I was trying to reach out in more of a like hey, it was a younger person that, you know, new to the field, just finished graduate school. I was reaching out so they wouldn't make a mistake. Like I was happy to engage in a discussion, but I was met with, no, I haven't had an interaction like that. I was so shocked.
Yeah.
And every interaction since has been the same. If I disagree with the group, the PhDs in particular, like Jeff Nippert's been great. Steve with Revive has been great.
Yeah.
People without PhDs don't have the ego clouding their ability to have a discussion. And I'm so appreciative of that. But when I've tried to engage with people that have PhDs on social media, a discussion can't be had. And I later found out that I was blocked on all posts. Like, I'm one of the few people that can push back on some of these study interpretations. And I realized that my comments didn't show up for anybody. I'm like, well, that's a shame. Like, I'm not here being mean. I'm not here bullying. And I'm just trying to move the conversation forward.
Yeah.
And then, so representing the Godot paper in that way, to me, at this point, is just dishonest, because I've pointed it out at least half a dozen times. Hey, we cannot use this as evidence. It's very problematic to use this as evidence. And then you started to see this trend where changes between groups were expressed as a percentage.
Yes.
To make seemingly similar changes look drastically different.
Yeah.
And I've put up a few thought experiments to get people to think about this. But in some cases, there will not even be a statistically significant difference. And they'll convert the percent difference in the change scores. You could go through changes in muscle size. Changes in muscle size are so small that you can go through papers that we all know, and the groups were the same. They're spoken of as if they're, because statistically they are.
Yeah.
And the changes are still 200% different because you're comparing 0.15 to 0.22, but like these, they're not different, because anyone that measures ultrasound knows that your cursor, like, you move it a little and it moves 0.1, not 0.02, you know? So we're talking about things that are more sensitive than any of the tools we're using to measure them. The cursor itself is bigger than, like, it's hard to even express how underwhelming these differences are. And yet on social media, it's using the math that the supplement industry has used for years.
Yeah.
To make us think that there's a compelling difference in an area where there's not. Now, this does not mean that long muscle lengths don't have the potential to be superior. This does not mean that choosing exercises that bias the length and portion aren't superior. It means you shouldn't use the Godot paper to make that point. And you shouldn't take very small differences and express them as a percentage difference in the change scores. If you stop doing those two things, we can then have a discussion on individual papers and see if we can get to the point where there's some agreement and there's some clarity.
Mm.
There's not a desire to do that.
Yeah.
And that's why moving forward, I'm worried about this particular area, because if you're willing to keep using the Godot paper, and if you're willing to manipulate math to make things look like that, I really hope other labs start studying this topic, because I don't know if it's a bias or just a desire to show something, but these are dangerous things in science, right? In science, you should just want to reveal the truth. And of course, everyone's going to say they want that.
Mm.
But when constantly it seems like there's a willingness to put out something that's a bit deceptive, I'm so cautious. And the data to date, there's some data in the quads that's somewhat compelling, so I find that interesting. But we're applying this to all exercises and all movements as if it's absolute truth.
Mm.
And it's funny. I like training at long muscle lengths for some exercises, not all exercises. But I've also told Holly, when we train on some movements, I love the shortened position. And I think we're being very foolish to write off other ranges of motion just because one muscle site that is measured looks better in a couple of studies, and with no mechanistic explanation as to why.
Mm.
Right? If long muscle lengths are targeting the distal portions, wouldn't short muscle lengths target the proximal portions? Like, there's no consistency in how logic is being utilized across the concepts here.
Mm.
And it just doesn't feel like science to me, what's currently happening. And again, I do not blame any of the social media people that are trying to communicate these things. But the PhDs
Should know
that
better.
are leading this, I think it's problematic right now.
Yeah, they're also creating their own echo chambers, and I've also been blocked by people just for posting, not even commenting on their post, but just posting different perspectives on muscle growth and training variables. And it kind of blows my mind that we're not interested in learning more and moving forward, and particularly what works best on an individual level. How should we apply these tools? Instead of, well, I've found the truth and I'm just not willing to entertain anything else. Yeah. I don't want to be proven wrong or challenged, even, because you have self-taught individuals that are claiming to know more and understand more about physiology and research because they have been studying various research papers and cherry picking and piecing together bits and pieces of that to create a model, and then completely ignoring the PhDs actually doing research, which are always, or generally at least, we have a few that aren't, but humble and open to being wrong. And, we need to learn more. We need to understand more. They are still curious and open for debates and exploring and challenging. So it's like they're taking personal ownership to concepts and theories and frameworks instead of, yeah, this is what I currently think. I might be wrong. And I would love to have a productive debate to perhaps figure out, when is it contextually a better answer than in other contexts.
Yeah, I've seen a lot of that as well, and again, I've had so many conversations as training in the gym. I'm like, it's so interesting that this person is so confident that they would call everyone else idiots that thinks differently. And it doesn't bother me in one sense, but on the other, it's like, instead of, saying that, myself or maybe someone else is an idiot or ill-informed or doesn't know what they're talking about, let's just like, why not have a discussion? Like, because I'm happy to be wrong, and if it
Hmm.
means I'm an idiot, that's okay, fine. You know, um, I
I
you
want to
never
be I want
stop
to be
learning,
right so much
and
that I would like to be proven wrong. You know.
yeah, I have been like I have been wrong several times, but like I've never had ego tied up in it, I don't think.
Hmm.
You don't. No one likes being wrong. You know,
Hmm.
um, but to me, it's fun because you honestly you learn more when you're wrong
Yeah,
because you remember it, you don't forget it,
I agreed.
and the whole long muscle length thing, the truth's probably somewhere in the middle. Like there's probably instances where it's a little bit better, but it probably gets washed out over time, and there's other instances where it's probably not true. Like
Hmm.
the truth is almost always somewhere in the middle.
Yeah.
But if you silence the people, so if you're here and you silence the people that are here, you never actually arrive to here. You just keep floating over here. And in the range of motion example, I think that's what's happening is you have overwhelmingly voices here. The voices here are all blocked,
Yeah.
like every single one
Exactly.
of them,
Hmm.
um, blocked or muted. And I think the people doing this are kind and courteous enough to the people that have large followings, and I think I don't know, there just seems to be this control of the narrative that's occurring, which is not in the nature of science at all.
Hmm.
I've had multiple public offers, and listen, I'm not a debate person. I'm not an argue person. And when people say, "Let's set up a debate," I'm like, no, let's set up a discussion, right? A debate kind of to me says someone's trying to win.
Hmm.
You know, in science, there shouldn't be wins. There should be discussions where both people learn.
Yeah.
Like that's what would happen, right? And that's what happened when I mean, I don't know if they considered it a debate or not. When I discussed volume on Revive Stronger with Menno and Josh,
Hmm.
who disagreed with me, but it wasn't a debate. It was a sharing of perspective, um, and me letting them know how I think. They let me know how they think, and hopefully, everyone that listens to that can refine how they think.
Yeah.
Um,
I really like
but
that.
I guess
Yeah.
the point I was making, so many times, and at least two or three, four times, there's been comments of so and so has offered to debate you,
Yeah.
and I'm like, yeah, I'd love to have a
Prove you
discussion,
wrong,
but
basically.
then I follow up. Yeah, I follow up, and then at the end of the conversation, like through the third party that's supposed to host it, like, yeah, they're not interested.
Hmm.
Um, so there isn't a desire to have a discussion, and that's honestly the reason I wrote a paper on long muscle lengths, because no one will have a discussion.
Hmm.
Like I and I know I'm not an influencer. I'm a scientist. The way to make a larger impact is to publish.
Yeah.
But I wrote a paper because no one would have a discussion, and I've never experienced science that way. But science is becoming new things to different people as social media evolves.
Yeah.
And I think getting a PhD has become a really valuable tool if you want to be an authority in an online space.
Hmm.
And I think it's unfortunate because I think it's our responsibility as PhDs to have the most humility and probably speak with the least authority, or the most skepticism and the most, I'm not sure. I think this is the case, but and these are the reasons I think it, but other people think this,
Hmm.
right? You should always share what you think, but say some people think this. I think they're wrong. Like,
Yeah.
you're allowed to think someone's wrong,
Hmm.
but that doesn't take away the fact that someone else thinks differently. So they have to coexist.
Yeah. Yeah. No, I really like the way you think, and I enjoy that Revive Stronger podcast. That was one of the best ones, I think, precisely because there were people with different perspectives, and they were all courteously and professionally sharing their views on that. And at the end, it kind of seemed like you weren't too far off. You just kind of had different interpretations. Like you said, yeah, for volume, I'm still of the opinion that 2 to 3 sets probably maxes out the growth rate from a given exercise. But once you add another, do a flat and an incline bench, then suddenly you can probably do some more sets for that muscle group simply because you're switching focus to different segments of that muscle. So eventually we kind of end up
Yeah.
at the
Yeah.
same point. And I guess that kind of gets me to wrap things up here. If we're speaking, because, most can get a beginner to grow, and, a lot of studies use untrained, and they call them, trained individuals, but they might have just 6 to 12 months of training experience. I know you have studied, and you're also, quite an advanced lifter yourself. Can you, based off of your views, your research background, and your experience, make some assumptions about the ranges of volumes and frequencies, and perhaps even rep ranges, and even should we have a periodized approach to that to get the advanced lifter to, let's say, take them from 90 to 95% of their genetic and hormonal ceiling? Do you have any guidelines, any ranges that you can provide to the viewers and listeners?
Yeah, I'll attempt to. So I, I like to think of training as a per session. So, in any meta-analysis, you'll see weekly volume and these sorts of things. And
Yeah.
I think there's a volume, there's a benefit to tracking weekly volume, but physiologically, I have to think of it as a per session basis because have you ever heard of my pizza analogy?
Yeah, yeah.
it's it's
Let's
it's
hear
it's a
it.
broken analogy, but
Hmm.
um, it's the idea that if you take the frozen pizza out, it takes 30 minutes to cook the pizza. You got to take it out of the freezer and put it in the oven for 30 minutes. If you take it out of the freezer and put it in the oven for 10 minutes on Monday, put it back in the freezer, put it back in the oven for 10 minutes on Wednesday, put it in the freezer, take it back out on Friday and cook it for 10 more minutes, you never fully cook the pizza.
Hmm.
So you can't have pizza, right?
Yeah.
So the point of the analogy is each stimulus has to be sufficient.
Yeah.
And the cooking of the pizza on Monday doesn't carry over to the cooking of the pizza on Wednesday. You're cooking a new pizza on Wednesday.
Great. Yeah.
So volume calculations often reduce physiology to math. And that to me is problematic because, you'll have people that think, you know, 3 sets in one session is the same as 3 sets spread out across multiple days. But it couldn't possibly be because in one, you're moving along this continuum of recruiting and fatiguing all the fibers. In the other scenario, you're recruiting and fatiguing the fibers, some of the fibers 3 times. So I like to think of volume as a per session basis. So on a per session basis, the big question becomes, well, how many sets do I do? Well, probably first you need to decide how many exercises you're going to do, because then we can maybe consider how many sets.
Hmm.
So it probably depends on the individual, depends on their goals. But a lot of this, a scientist is always expected to lean on research to give the most precise recommendations. But like we discussed, research has not been conducted the way I think. And I'm not saying the way I think is correct, but it's still the way I think.
Hmm.
And I think the current volume literature is lacking the variety. But I would tend to think that 2 to 3 different movements utilizing the muscle fibers to provide variety are probably the way to maximize muscle growth. and maybe 2 to 3 times per week. But that frequency is going to depend on the genetics and the recoverability. And I think that 2 to 3. So if that's 2 to 3 exercises, um, so that's I guess that's 18 to 27 sets.
Mm.
And I kind of got laughed at a little bit because my volume recommendations at the end of the Revive Stronger were some of the highest.
Yeah.
And I had to explain critiquing the volume literature is different than critiquing volume. I tend to think a lot of people do too much volume, but
Mm.
that's because they're doing more of the same thing.
Yeah.
Um, I think there's potential that doing more of a different thing, the same muscle, provides a benefit. I think it's diminishing returns, honestly, just like we discussed.
Yeah.
Maybe you need 3 to 4 sets on your first movement with a muscle, and maybe you just need 1 to 2 sets on the follow-up exercises that use that same muscle.
Mm.
Now, again, this is just a way of thinking. I don't have data for this, but I could, in my mind, come up with the rationale as to why that could make sense.
Mm.
Um, so, a few movements, 2 to 3 times a week, 3 to 4 sets. I mean, I think you can get away with 2 in some cases. And again, frequency is a tough one just because the data is not super strong, but I would, that's mostly going to depend on people's schedules anyways. It's going to depend on their training split,
Mm.
all these sorts of things.
Yeah.
So
I like to kind of get
maybe that
people
comes out to 8.
to experiment and just, when are you recovered?
Yeah.
Play around with it and see where is your
And
sweet spot.
that ties right back to the art of coaching.
Yeah.
Which we talked about, right?
Mm.
You can't have one without the other.
Mm.
And you need flexibility. A lot of people want to have this rigidness to adhere to the scientific principles,
Yeah.
right? But that doesn't work. That's not realistic. And research hasn't studied you specifically. So, and then the periodization part, I guess you had periodization as well. I have unique thoughts on periodization in that periodization to me, I've looked at the origins of periodization based on Hund-Selye's general adaptation syndrome. And a lot of people perceive periodization to be changing what you do from Monday to Wednesday to Friday, the intensity and the volume, or changing volume across 8 weeks. To me, changing volume should be with purpose. So if you're doing less volume, it's because you want to promote recovery. It's because you're not recovering.
Yes.
If you're doing more volume, it's because you're able to recover from that volume. So I think I don't like the idea of subscribing to a periodized programming model for the sake of subscribing to it. That leads to silly things like doing low volume periods when there's no reason to. When you could adapt to more, like you're literally holding back. And maybe there's coaches out there that could say, well, this is planned. It's to prevent something in the future. That's fine. Oftentimes I might come after a model, and it's not to necessarily say that model is wrong. It's often to say the data that you're using to support this doesn't say what you think it says. But I think periodization as an overall stress management tool is valuable. Yeah. And I've written on this a little bit where, periodization was developed in the context of sport. And if you look at the early linear models, volume was really high when there was no in-season, there was no sport practice.
Yeah.
And what you'd see over time, there's a decrease in volume over time, but at the same time, volume of, let's say, playing football or playing soccer was increasing. So the reason that volume was decreasing was because another stressor was increasing.
Yeah.
And the way I like to think about periodization, the way I teach it to my students, is that periodization has to happen in the context of your life and your other stressors. And you consider all of the stressors and determine which direction does volume and intensity need to go. So if you're going through a period of life where you're very busy, you have a lot going on, it might be time to periodize against those stressors and decrease volume. Because most people aren't periodizing alongside sport. Some people are. If you're periodizing along sport, it becomes very simple. Low volume in the weight room when there's high volume on the field or high volume on the court. But when you're not periodizing against a competing stressor, the competing stressor becomes your life, your recovery, your work, and everything else. And that's kind of how I view periodization, if that makes sense.
Yeah, makes a lot of sense. And as you mentioned earlier, you generally consider whether you do higher or lower reps seems to have the same growth stimulus. So do you think that, to me, I kind of have observed that if you only do low reps for a while, you tend to lose out on adaptations that higher reps provide, and introducing higher reps to that seems to improve results and vice versa. And I'm not really even sure we need to systematically, have periods of higher and lower reps. And obviously, the number of sets you mentioned and the frequency is within the context of a sufficiently applied effort. So if you're a person that just, subconsciously or consciously hold back on each set, you can probably do more sets to compensate for that. But the current, idea is that lower reps are way less fatiguing, and so we can just do more sets of that and we can recover faster from that. But that doesn't seem to be the case. So should we just, my question is, should we just pick a rep range that we enjoy doing and switch to another one when we don't enjoy that anymore? Or do you have any system of applying that?
Yeah, I don't necessarily have anything that I recommend people subscribe to. I think it depends on goals ultimately. So if the goal is just growth, then maybe it's of less consequence. If you care about strength, you're obviously going to have to lift heavier, at least occasionally.
Yeah.
And then, I think for injury prevention purposes, I think there's a value to training heavy that you just don't get that same value with lower load training. And maybe the jury's still out to some extent, but if you look at most of the injury prevention research or the literature, it's heavy eccentrics that seem to really protect against injuries. So I wouldn't exclusively recommend training with low loads just for that reason. Now, you could argue, well, high loads come with greater risk of injury because it's just a higher load. So there's that trade-off. But I believe they have unique and distinct benefits. That maybe some people would tend to believe that there's greater cardiovascular benefits, at least local vascular benefits to some of the lower load, higher rep training. And again, this is like piecing studies together in a way you shouldn't do, but that's how my mind works. And there's some evidence that capillarization enhances growth, particularly for older individuals. So, you could come up with a reason to have that variety. I tend to like variety to some extent, so I think people should try both, incorporate both when appropriate, but don't feel like you necessarily have to. And make sure your training meets your goals.
Yeah, fantastic. I couldn't agree more, I guess. So my final question to you would be, do you have any interesting studies and projects in the pipeline that you're able to share?
Sure. Yeah. So I think I've mentioned before on other podcasts that we're replicating the show and found volume study. So we're about halfway through. We have one more wave to do, maybe possibly two more waves. Where we're trying to get a larger sample size, and we've included a control group, and we've also included additional post-testing to see if we do have swelling at that post-testing measurement time point. So that's one thing that we're working hard on in the lab, and the semester is just about to kick off in 2 weeks, so I'm excited to get started again. Other than that, we have some acute studies, like some other stuff looking at swelling. And I also came up with a study that just induces a change in muscle size. And it's just to demonstrate this idea that a 5% change in CSA and a 5% increase in muscle thickness are not the same thing. So this is more like to help people conceptualize and understand research, which, I think that's important.
Yeah.
Um, one of the reasons why my volume paper was so misunderstood, like it got reviewed in reps, and they missed the point of the paper. Stronger by Science talked about it, but the paper was written from the perspective of someone that images muscle with ultrasound,
Mm.
and it was so counter to the narrative in the industry that the industry just assumes it's wrong.
Mm.
And I think it's important to continue to try to provide tools to help people understand, so they can actually interpret your research correctly. So we have some work focusing on that. I have some projects coming up with this new device called Speed. There's a company called Speed. They make a product that's like isokinetic. So we have some isokinetic stuff coming up. And then I'm working on a glute and shoulder with like a hip abduction. We're still working out the details there, but it's going to be like a position. I guess it's related to longer muscle lengths and these sorts of things. But focusing specifically on glutes and shoulder growth, cable and dumbbell in the upper body, and then just manipulating muscle length and comparing exercises in the lower body. So again, that one we're still ironing out the details, but we have a huge busy semester ahead of us, and
Sounds like it.
yeah, I'm looking forward to it. It's going to be a lot of fun.
Awesome. So where can people find you, and where are you on social media, and where are you most active?
Yeah, so I'm on Instagram. Let me make sure I get the name right. It should be at Samuel Buckner. Where I post our lab's latest research. I have Twitter. I guess I don't use Twitter as much, so Instagram's probably the best place for people to get a hold of me. I have the research review that me and Holly recently launched. So I don't know if people are interested in just hearing our takes on research, which is, those are what research reviews are. And I just think there's such incredible value in getting diversity of perspective. And the reason we started that is I didn't see a diversity of perspective existing online.
Mm.
So that's called Be a Brain, and every month we review 4 different papers. So that's been a fun project.
I'm a subscriber. So yeah.
Aside from that, I think was that.
I'm a subscriber already, so yeah, I can highly
Thank you.
recommend it. So
I appreciate that, and I hope you enjoy it.
yes,
It's been fun. Other than that, I always tell people I'm in the comment sections. I'm trying to interact and engage on these science posts because, I think that's funny enough. That's where we probably met, and I've met a lot of people that way. Just like, oh, hey, that's a great point. Have you thought this? So I interact a lot on scientific content, I suppose. So
fantastic.
yeah.
It's been an honor, Dr. Buckner, to have you on. I really, really enjoy your posts, and I love the way you think. And having you on here was, the highlight of my week and month, I would say. So I really enjoyed our conversation.
Well, thank you so much for having me on, and thank you for saying that. You're too kind. I thought the discussion was awesome, and hopefully at some point we can come back on and talk some more because I really enjoyed it.
Awesome.